Welcome, everyone. In this lesson, we're going to kind of introduce the terminology for discussing one more major derivative rule. And that derivative rule, well, you may have guessed, it's called the chain rule. We're not going to get to the chain rule in this video. We're just going to introduce the terminology that we're going to use to ultimately discuss the chain rule in class. And so far, as we've been kind of learning about derivatives and how to differentiate various functions, we've seen that for each algebraic operation, there's kind of a derivative rule that goes with it. So if we add two functions, well, we've seen how to differentiate what happens when we the sum of those two functions. Or if we want to subtract one function from another, well, we've seen that there's a derivative rule for how to handle that subtraction. Same thing with multiplication and division, product rule and quotient rule. Now there's one other way that we're going to investigate how to actually combine two functions together. And this is called a composition. So a function h is the composition of functions f and g if h of x is equal to f with g of x plugged in. So if we have two functions, there's various ways we can combine those two functions together to get a brand new function. We can add them, we can subtract them, we can multiply or divide. And the other thing we can do is we can take one function and plug it into the other function, essentially. And that's called a composition. And so with a composition, there is an order of doing things. And so when we talk about looking at the composition of two functions, usually we call one of the functions the outer function. And this is the thing that kind of happens last. So in this case, our formula here, f, function f, this is going to be our outer function. And the thing that gets plugged in to that outer function, in this case, g, we're going to call that our inner function. It gets plugged into the other function. And the way to kind of picture composition, it helps to almost think of functions and composite functions as like an assembly line. So if we have, when we evaluate functions, we start with our input x. So our input is going to be our variable, x. And what happens with a composition is, first of all, x gets plugged into, in this case, function g. So we're going to take our input and we're just going to plug that into our inner function, function g. And what function g does is it takes that input, changes it into something else, and it gives us out the output g of x. That's what we call the output of function g. And then the idea behind a composition is then this g of x just kind of works its way down the assembly line and it gets plugged into our outer function. So we're going to take this and immediately it works its way on down the assembly line and goes into function f. And what function f does is it takes that input g of x, does something to it, and it gives us out ultimately the output here that we end up with, f of g of x. And this is our outer function working its little bit of magic. And then we end up ultimately with our output. And so the idea behind a composite function is we can view this entire process as just kind of one function of its own. And that's what we call function h. So we can think of this whole thing as just taking an input and it just goes into function h. And h does its own thing and spits out h of x. So we can just view this whole inner function, outer function thing as just one function of its own. So input x goes into this whole procedure here, and what happens is out comes the output f of g of x. Or if we wanted to rename it, we could call that h. All right, so you want to think of composition as kind of like this assembly line approach. And let's try an example where we investigate this. So in this case, we have two functions, f of x, which has the formula x minus 1 over x plus 1. And then we have a second function, g of x, which is x cubed. And what we're going to do in this example is we're going to calculate two different compositions. Now, we're going to use both of these functions, but the result is going to be different. So for the first one, we're going to calculate f of g of x. And then for the second part, we're just going to reverse the order, and we're going to calculate g of f of x. So again, if we kind of go back to that assembly line, if you start moving parts of your stations of your assembly line around, you would expect to get a different output. So if instead of going into function g first, we went into function f first and then moved everything around, you're going to expect a different output. And that's what we're going to see in this example. So let's start with the first one. All right, so let's see how this is going to work. And what do? Our inner function here is g of x, is g. So that's where we're going to start. We're going to start with our inner function. All right. And what we can do is, where I see this g of x, I can just plug in x cubed, because that's what g of x is. Okay, so let's do that. So we're just going to essentially evaluate f, and we're going to plug x cubed in wherever I see a variable in my formula for f. So essentially, we're now just going to plug in x cubed instead of the usual x. So when we evaluate f of x, essentially what we're doing is we're taking x and we're just plugging it into this formula. But now, in order to evaluate f of x cubed, we're going to replace each of these x's with an x cubed. So let's see what that's going to look like. And, normally x would be, or function f would give us x minus 1 over x plus 1. But instead, we're going to replace each of these x's that we see here with x cubed. So we're going to get an x cubed here and an x cubed here. So it'll be x cubed minus 1 over x cubed plus 1. All right. And that's it. That's our composite function. So what happened here is x started our assembly line. It first went into function g, which gave us out x cubed, and then we took x cubed and plugged it into function f, which gave us the x cubed minus 1 over x cubed plus 1. So now let's try changing the order. And our inner function down here is going to be f of x. So that's what we're going to start with. So let's see how this is going to look. So we're going to do the composition. And now let's replace f of x with what we know f of x actually is. So let's go back up. F of x is right here. It's this fraction. So we're just going to take this fraction and we're going to replace f of x there. So we end up with x minus 1 over x plus 1. And then this is the gadget. This is the thing that we're going to plug into function g. So we're going to take this whole big fraction and we're going to plug it in to function g. Well, what normally happens with function g? It's x cubed. Well, not anymore. What we're going to do is we're going to take this whole thing and we're going to plug that in right here. So let's get rid of that x. And instead, we're going to plug in our fraction. So it'll be x minus 1 over x plus 1, and we're going to cube that whole thing. And that's it. That's our composition in this case. And so the thing to note here is that if we change the order, we end up with two different results. All right. So another way to kind of think about compositions is this is actually having the two functions already and combining them. When we get to the chain rule, when we start trying to investigate the chain rule, we're actually going to want to go the other way. So we're going to have functions like this or functions like this, and what we're going to want to do is kind of break them apart and figure out, well, what are the two functions that were combined together? And so that's what we're going to do in example 2. We're going to try to write each function as composites of simpler functions. So we essentially want to find what those two other functions were that were combined together. And the way we're going to do this is we want to figure out what the inner function is, and then what the outer function is. So this is the way we want to kind of frame what we're doing. And so usually the inner function is kind of the thing that happens first to x. So when we look in our formula here for our function, so we have this function h of x. Let's look at this first one. X to the power 5 plus 9x plus 3, and that whole thing gets raised to the power 8. So the inner function is usually the thing that happens to x first. And the outer function is usually the thing that happens to our formula last. So the outer function is kind of like the very last thing that happens. And so in this case, the inner function is going to be what's inside the parentheses here. And that's kind of a good way to think about the inner function. If you see a set of parentheses, well, then the inner function is usually going to be whatever's inside the parentheses. So our inner function here, let's call it g of x, and it's going to be that power function, or that polynomial, x to the power 5 plus 9x plus 3. All right, so imagine just kind of clearing all this out. What do we have left? Well, the only thing left is this thing that's raised to the power 8. So when we look at this, that's going to become our outer function. So what do we have left after we kind of clear out this inner function here? Well, we have a parentheses, and then raised to the power 8. And normally for a function, we need a variable there. So we're just going to make our variable x. So our outer function here is going to be x raised to the power 8. And if you were to kind of try and redo the composition, what we've done is we've kind of broken this function apart, and we found kind of two smaller functions or two simpler functions that make it up. It'd be good practice to try out the composition as a way to check your answer. So what you would want to do is figure out what the composition is. And so the inner function, this is the thing that happens first. So it's inside the parentheses. And then the outer function, this is sort of the part of our function that's on the outside. It's the last thing that gets done. So if we were to type this, say, into a calculator, the first thing I would do with x is raise it to the power 5. Then I would add to it 9x plus 3. Then I would add 3. And then the last thing I would do is I would take that whole result, whatever I got from doing all that, and the last thing I would do is I would raise all of it to the power 8. So usually the outer function is the last thing that happens. And then the inner function is usually what happens inside the parentheses. And so, check this out. It'd be good practice. Now, we can do the same thing for the second one here. We have this function k of x, and it's the square root of 4x squared plus 1. And we can write this function as the composition of two simpler functions. So again, we want to go through the same process. We want to think about, well, what's an inner function and what's the outer function? And with these, there's usually more than one way to kind of break the function apart. So there's not always one correct answer here. There might be many correct answers. So we're just showing one specific way to do this. So there's other ways to think about inner functions and outer functions for these. All right. So for the inner function, again, what we're looking for is we're looking for what happens inside of another function. And we see that if we kind of read through what this function is, it's the square root of 4x squared plus 1. So if I were to kind of think about typing this into a calculator, well, what would I do? The first thing I would do with my x value is I would square it. Then I would multiply by 4. Then I would add 1 to that. And then the very last thing I would do is I would take the whole result from doing all that, and I would do the square root. And that would be it. So the last thing I do for this function is the square root. And that's going to be my outer function. So I'm going to call my outer function here f, and it's the square root. And just to give it a variable, I'm going to throw an x under there. So my outer function is the square root of x. Now what about my inner function? Well, the inner function is kind of everything inside of the square root. So again, with the inner function, we're looking for the terms that are inside of the other function. And in this case, I see it right here. 4x squared plus 1. And we'll call this g of x. All right, so there's our inner function. And again, it would be good practice. Try and check. Do the composition. Take g of x, our inner function, and plug it into our outer function f. And you should get that this composition ends up being precisely what we have here. So use this as a way to kind of check your decomposition. And really just to kind of stress, so this is going to be an important concept, being able to kind of break functions apart based on inner and outer functions here. But to really kind of stress this strategy, usually the inner function is what's inside the parentheses. Our usual routine of trying to differentiate a square root function, what do we normally do? Well, the first thing I normally recommend is rewrite it as a power function. So I would recommend rewrite this as 4x squared plus 1 raised to the 1/2 power. And when we do this, we see a nice set of parentheses here, and that should kind of tell us what's inside those parentheses is most likely going to be the inner function. All right, so this is all kind of leading towards the chain rule, and we're going to get to this in class. But essentially, this chain rule tells us how to differentiate the composition of two functions. So if we have g of x, one function, getting plugged into another function, f, so we have this composition, the chain rule is going to tell us how to differentiate that. So we'll see you there in class. Bye-bye.